Good morning guys. So let's start with another topic, that is denture based resin or acrylic resin. So from this particular topic you can expect at least two questions, because it is a very vast topic and very important for your exam point of view also. So starting with this, basically what is denture base? It is defined as that part of the denture that rests on the foundation tissue to which teeth are attached. So denture base material is any substance of which denture base may be made. These are denture. This is denture base and this is denture base material from which the denture base is made. So classification of the denture material according to these are the denture based material classification. So according to this, it is divided into two parts, that is non-metallic and metallic. In metallic, your example is acrylic resin, vinyl resin. In your metallic, you have cobalt, chromium, gold alloys, stainless steel. So denture based material, it can be temporary, it can be permanent. For temporary, you have self-cure, shellac base plate wax, injection molding resins, and metallic bases. In the permanent, you have heat cure denture resins, light cure resins, pore type resins. So, according to ANSI and AD specification number 12 and ISO 1567, there are 5 types of polymers, you can say, or resin polymers. First is heat polymerizable polymers, which consist of class 1 and class 2. In class 1 you have a powder and a liquid. In class 2 you have a plastic cake. In type 2 it is auto-polymerizable polymers having class 1 and class 2. Same way, in class 1 you have powder and a liquid, but there is a change in class 2. In type 2 there is a powder and liquid pore type resins. In type 3 you have a thermoplastic blank or powder. In type 4 these are light activated materials, and type 5 these are microwave cured materials. So what all are the ideal requirements of the dental resins? So dental resin should be tasteless, odorless, non-toxic and non-irritant to the oral tissues. It is aesthetically satisfactory, that is, it should be transparent or translucent. It should be dimensionally stable. It should be insoluble and impermeable to the oral fluids. It should have a low specific gravity, and obviously it should be economical. What all are the uses of resin in the dentistry? It is used in the fabricating the dentures. It is used in the artificial teeth, the tooth restoration, example the fillings, inlays and laminates. It is used in the inlays and the post-core patterns, used in the models, splints and stents, and custom impression trays. So starting with the dental polymer, what is polymer? Polymer is a chemical compound consisting of a large organic molecules formed by the union of many repeating smaller monomer units. These are known as mer units. These are the individual mer units, and when they combine they make a chain. This is known as polymer. So what is monomer? The molecules from which the polymer is constructed are known as monomers. What are copolymers? Polymer molecule may be prepared from a mixture of different types of monomers, and they are called copolymers. So molecular weight for various denture polymers and of the cross-link resins. So what are the molecular weights? The average molecular weight for the various denture polymer ranges from 8,000 to 39,000. cross-linked resin teeth may have in excess of 6 lakh. So basically, what do you mean by the degree of polymerization? It is defined as total number of mers in a polymer. Total number of mers in a polymer. It is known as polymerization. The higher the molecular weight of the polymer made from a single monomer, the higher the degree of polymerization. So the strength of the resin increases with increase in the degree of polymerization until a certain molecular weight is reached. So physical structure of polymer molecule. So basically it has three basic structures, that is linear, branch and cross-linked polymers. In your linear you have homopolymer, random copolymer, block copolymer. In the branch you have branch homopolymer, branch random, branch graft, and third one you have cross-linked polymer. So basically, what is polymerization? The term polymerization refers to a series of chain reactions by which a macromolecule, means a larger molecules or the polymer, is formed from a group of smaller single molecules. It is known as monomer. Polymer plus monomer is when you heat it, you obtain the polymer plus liquid and powder. Now coming on to the polymerization. Types of polymerization. There are two types of polymerization, that is the addition polymers and the condensation polymers. So addition polymers are when the similar molecules are combined. This reaction is known as addition polymerization. I repeat, when the similar molecules are combined, it is known as additional polymerization. In this what happens is the monomer is repeated many times with the polymer, but there is no byproduct is formed. Example, your polymethyl methacrylate. I repeat, the addition polymerization is when the similar molecules are combined, it is known as additional polymerization. In this, the monomer in the addition polymerization is repeated many times with the polymer, so there is no byproduct is formed. And the example of addition polymer is your PMMA, that is your polymethyl methacrylate. Coming on to the condensation polymerization, this involves combining of two dissimilar molecules into a third entirely different product. It is known as condensation. In addition polymerization, it is where the two similar molecules combine, and in this it involves, in condensation polymer, it involves the combining of two different polymerization dissimilar molecules into a third entirely different byproduct. Example is impression compound and acrylic resins. So coming on to the condensation polymerization, as you all know, I've already told you that it involves the combining of two dissimilar molecules into a third totally different molecule. So condensation resins are divided into two groups: those in which polymerization is accompanied by repeated elimination of small molecules, and in second, those in which the functional groups are repeated in the polymer chain. The mers are joined by functional groups. So what is addition polymerization? I have already told you that when the similar molecules are combined, it leads to the formation of additional polymerization. So most of the resins are produced by addition polymerization. There is no change in the chemical composition and there is no byproduct is formed. As I have already told you, the structure of the monomer is repeated many times in the polymer. Coming on to the chemical stages of polymerization, there are 4 stages: the induction stage, the propagation stage, the chain transfer, and the termination. Coming on to the induction stage, the induction or the initiation period is that time during which the molecules of the initiator becomes energized or activated and start to transfer the energy to the monomer. I hope it is clear to all. So basically there are 3 induction systems: the heat activation, the chemically activated, and the light activated system. Heat activated, the free radical liberated by heating the benzoyl peroxide will initiate the polymerization of the methyl methacrylic monomer. An example is your denture based resin. It is very important. Just keep this in mind and go through the these slides twice. Coming on to the light activated, in this the photons of the light energy activate the initiator to generate the free radical. That is, what are your initiator? It is benzoyl peroxide. An example is composite resin. Coming on to the chemically activated, the system consists of at least 2 reactants. When mixed, they undergo chemical reaction and liberate free radicals. Example is self-cured resin. Coming on to the next, that is propagation. Once the growth has started, the process continues with a considerable velocity. Theoretically, the chain reactions should continue with evolution of heat until all the monomer has changed to polymer. In this, basically the chain reaction should continue with the evolution of heat until your all monomer has changed to the polymers. Actually, the polymerization is never complete in this. Coming on to the chain transfer, the chain termination can also result from chain transfer. Here the activated state is transferred from an activated radical to an inactive molecule. Thus, a nucleus of growth is created. Coming on to the last, that is termination. The chain reaction can be terminated either by direct coupling or by exchange of hydrogen atom from one growing chain to another. So coming on to the copolymerization. So basically, what is copolymerization? It is the resin formed by 2 or more chemically different monomer. That is called copolymer, and the process is called copolymerization. I repeat the definition: the resin formed by 2 or more chemically different monomer. This is called copolymer, and the complete process is known as copolymerization. So the macromolecule may be formed by polymerization of a single type of structural unit. In order to improve the physical properties, it is often advantageous to use 2 or more chemically different monomers as a starting material. So the polymer thus formed may contain units of these monomer. Such a polymer is called copolymer, and the process is formation is known as copolymerization. So I have told you in a very easy language, in a very simple language, that the resin formed by 2 or more chemically different atoms. See, the resin formed by 2 different atoms. This is monomer A, monomer B. When these are combined, it forms the copolymer, and the process is known as copolymerization. Now coming on to the types of copolymer, there are 3 different types, that is random type, graph type, and block type. So block type. Coming on to the random type. The random type of copolymer, the different monomers are randomly distributed along the chain. See, This is the chain, and it is randomly distributed. The two monomers, these are randomly distributed along the chain. This is known as random polymers. The graph polymer is a sequence of one of the monomers are grafted onto the backbone of the second monomer species. See, one is grafted to the backbone of another. Can you see this? Third is the block type. The identical monomer units occurs in a relatively long sequence along the main polymer chain. The identical monomer units occur in a relatively long sequence, then along the main polymer chain. I hope it is clear. Now, importance of copolymerization. It is to better the physical properties of resins. Many useful resins are manufactured by copolymerization. For example, with the help of your cross-linking and your monomer different, etc. Now, cross-linking. Basically, what is cross-linking? It is the formation of the 3D molecules by interaction between the individual linear chain. I repeat, it is a formation of 3D network. It forms a 3D network. It is the formation of 3D molecules by interaction between the individual linear chain. So the formation of chemical bond or the bridges between the linear polymer is referred to as cross-linking. It forms a 3D network. Plus, most important point is it decreases, please note it down, it is not written over here, that cross-linking decreases grazing and water resorption. Next is cross-linking agent mainly to improve the graze resistance. These 2 points are very important. So, application of cross-linking. The more recent acrylic resins are of cross-linked variety. It improves the strength and decreases the solubility and the water absorption. As I've already told you, it increases the water solubility, water absorption. Acrylic teeth are highly cross-linked to improve its resistance to solvents, grazing, and surface stresses. The acrylic teeth which you are used in your prosthodontics for the teeth arrangement, complete denture arrangement, or your removable partial denture. So what all are the physical and the chemical stages of polymerization? The physical stages, the wet sand stage, the sticky stage, the tub stage, the rubbery stage, the stiff stage. In the chemical stage, you have induction, propagation, termination, chain transfer. So how does inhibition of polymerization takes place? The reaction of polymerization are inhibited by impurities and oxygen. In impurities, when impurities react with the activated initiator or any activated nucleus or with an activated growing chain to further growth, to prevent the further growth. Example is hydroquinone. So it is added to prevent the polymerization of the monomer during storage. Oxygen, in the presence of oxygen, also inhibit the polymerization. What are plasticizers? Plasticizers are the substances added to resin to increase the solubility of the polymer in the monomer to decrease the brittleness of the polymers. There are 2 types of plasticizer, the external and the internal plasticizer. So now coming on to the very important topic. Now you should be thorough with the composition because it is very confusing. The composition of heat cure acrylic, the composition of self cure acrylic, the composition of chemically cure acrylic. It is very confusing. So you have to be thorough. You have to mug it up. Starting with the composition of heat cure acrylic resin, that is coming with the liquid. contains methyl methacrylate which act as which plasticize the polymer. Dibutyl phthalate, it acts as plasticizer. The glycol dimethacrylate, this acts as the cross-linking agent which reducing the grazing. Hydroquinone, it acts as the photoinitiator, it acts as the inhibitors, it prevents premature polymerization. Coming on to the powder composition, polymethacrylate, it is the major component. Ethyl or butyl methacrylate consists of 5%. These are copolymers which improve the properties. Benzoyl peroxide acts as an initiator. Compounds of mercuric sulfide, cadmium sulfide, etc., it acts as a dyes. Zinc or titanium oxide, it acts as an opacifiers. Dibutyl phthalate, it acts as the plasticizer. Inorganic fillers like glass fibers, zirconium silicate and alumina, etc., these improves the physical properties like stiffness. Dyes synthetic nylon or acrylic fibers, these are helps to stimulate all the capillaries. So now before coming on to the self-cure acrylic resin, I have some MCQs which was asked in your competitive exam. First MCQ was from the heat cure was, the methacrylate is the monomer used in heat cured denture based resin. I repeat, methacrylate is the monomer which is used in heat cured denture based resin. Next MCQ was, to cure a heat cured resin, a proper heating cycle is necessary. Why? Answer is to prevent the porosity. Coming on to the next MCQ, polymerization of heat cured methyl methacrylate is initiated by, your answer is benzoyl peroxide free radical. I hope the MCQs are clear to you. Coming on to the composition of self-cure acrylic resin. In the liquid you have the methyl methacrylate monomer which dissolves and plasticizes the polymer. Dimethyl p-toluene, it acts as an activator. Dibutyl phthalate, it acts as a plasticizer. Glycol dimethacrylate, it acts as a cross-linking agent. And hydroquinone, it acts as an inhibitor. In the powder you have the polymethyl methacrylate and the other copolymers. The basic function is to dissolve by the monomer to form a Duff stage. Benzoyl peroxide acts as an initiator. Compound of mercuric sulfide and cadmium sulfide, it acts as a dyes. Zinc or titanium oxide acts as an opacifiers. Dibutyl phthalate acts as a plasticizer. Dyed organic fillers and inorganic particles like glass fibers or beads, these act as an aesthetic purpose. So before coming to this, I have some MCQs regarding your self-cure acrylic resin. Actually, I have a lot of MCQs regarding the self-cure acrylic resin because it is a very important part. See, the whole question was made from your composition of self-cure. Okay, first MCQ was, use of dimethyl p-toluene. The p-toluene is indicated for, your answer is chemical polymerization. I repeat, use of dimethyl p-toluene is indicated for, answer is chemical polymerization. Acrylic cold cure produces heat during polymerization. This is your next MCQ. Acrylic, that is cold cure, produces heat during polymerization. Next MCQ is, hydroquinone is added to methyl methacrylate monomer. Why? Answer is to prevent the polymerization during storage. Hydroquinone is added to the monomer. Why? To prevent the polymerization during storage. Next is cross-linking in the denture-based resin is contributed by cross-linking. You can see cross-linking agent is the glycol dimethacrylate. See, the simple question and the straight or as it is question are coming, but you have to mug the the composition. Next question is, next MCQ was, to prevent the porosity in the self-cure acrylic resin, curing should be carried. Your answer is under vacuum pressure. It was asked in PJ exam. Next MCQ was, in self-cure acrylic resin, the activator is, your answer is your tertiary amine. It was also asked in your PJ exam. Next is, boiling of methyl methacrylate is, your answer is more boiling point of water. It was asked in your AIPJ exam. Next question is, polymerization of self-curing resin takes faster in, your answer is hot water. Next MCQ is, cold cure acrylic expand in water by, your answer is 1% by volume, 0.23% by weight. It was asked in your NEET exam. So apart from this, let's discuss the difference between the self-cure and the heat-cured, which is very important. Self-cured heat is not necessary for polymerization. In heat-cure, heat is necessary. In self-cure, there is greater porosity. Porosity is less in heat-cure. It has a lower average molecular weight. It has a higher molecular average weight. Self-cure has the higher residual monomer content. Heat-cure has the lower residual monomer content. Radiological properties, it shows greater distortion. Heat-cure shows less distortion. Self-cures shows more initial deformations. Heat-cure shows less initial deformations. Self-cures increase creep and slow recovery, and it creates less creep and quick recovery. Self-cure has the poor color stability. Heat-cure has the good color stability. Self-cure are easy to flask. Heat-cure are difficult to flask. Increased rate of monomer diffusion at the high temperature in the heat-cure. So coming on to the chemically activated denture-based resin. In this, these are chemically activated, as the name suggests. Chemical activation is accomplished through the addition of tertiary amine, such as the dimethyl para-toluene, to the liquid. Upon mixing, the tertiary amine causes the decomposition of benzoyl peroxide. Consequently, free radicals are produced and polymerization is initiated. Coming on to the composition, it is the PMMA, polymethyl methacrylate in the powder. We dissolve the monomer to form the dove. Benzoyl peroxide act as an initiator. Compound of mercuric sulfide and cadmium sulfide act as a dyes. Zinc and the titanium dioxide act as opacifiers. Dibutyl phthalate act as a plasticizer. Dyes organic fillers and inorganic particles act as is basically from the aesthetic part. Composition of liquid methyl methacrylate, it dissolves or plasticizes the polymer. Dimethyl toluene, it acts as an activator. Dibutyl phthalate acts as a plasticizer. Glycol dimethacrylate 0.1 to 2% act as the cross-linking agents which reduce grazing. Hydroquinone 0.006% act as an inhibitor. So before coming to this, I have some important question regarding your chemically activated. Question number 1, residual monomer content of chemically activated resin is. Your answer is 3 to 5%. I repeat the question. Residual monomer content of chemically activated resin is. Answer is 3 to 5%. During polymerization of acrylic resin, your next question is, during polymerization of acrylic resin above 60 degree of Celsius of temperature, benzoyl peroxide forms free radicals. It was asked in your AIMS exam. I repeat the question. During polymerization of acrylic resin above 60 degrees Celsius of temperature, benzoyl peroxide forms the free radical. These benzoyl peroxide above 60 degrees of Celsius of temperature forms the free radicals. So coming on to the steps of compression molding technique. Number 1, preparation of the wax denture pattern, preparation of the split mold, application of separating medium, mixing of powder and liquid, packing, curing, cooling, divesting, finishing and polishing. Coming on to the compression molding technique, periphery of the flask should be in the level with the rim of the flask. Occlusal plane parallel to the base of the flask. Your occlusal plane, this is your occlusal plane, that is should be parallel to your flask. Tilting of the cast, a retromolar pad or the retromolar pad or in the upper, your tuberosity should be protected. Checking the seating of the flask members, distance from top to lid, it should be 6 mm. Very important, painting on the separating media like cellulose, lacquers, solution containing alginate, compound, calcium oleate, soap, sodium silicate, starches were introduced. Tin foil acted as a substitute. Most popular water-soluble alginate solution produced thin, relatively insoluble calcium alginate film. So you have to apply the insoluble calcium alginate film over your cast. So sodium alginate, see, it is a very important topic, sodium alginate solution as well. You can expect a question from this topic also. So it is very important, please listen carefully. Sodium alginate solution, it is water soluble. It reacts with the calcium of the plaster or the stones to form a film of insoluble calcium alginate. From sodium alginate, when it reacts with the calcium of plaster, it forms the calcium alginate. So composition is very important. It contains 2% of sodium alginate in water, consists of glycerin, alcohol, sodium phosphate and preservative. Application, applied using brush, coating only on plaster surfaces. 1 or 2 coats are applied. Setting reaction of sodium alginate, it reacts with the calcium of the plaster or the stone to form of insoluble calcium alginate. Sodium alginate solution. Precautions to be taken. Waxes or oils remaining on the mold surface will interfere with the action of the separating medium. Mold should not be warm, not hot. Continuity of the film will break if the mold is steaming hot. So your mold should not be warm, not hot. So avoid coating on teeth. Polymer monomer interaction, sandy, stringy, dove-like, rubbery or elastic stiff. During sandy stage, little or no interaction occurs on the molecular level. Polymer beads remain unaltered in this stage. Later, mixture enters the stringy stage. Monomer attacks the surface of individual polymer beads, and the stage characterized by stringiness. Subsequently, the mass enters a dove-like stage. On molecular level, increase the number of polymer chains are formed. Clinically, the mass becomes a pliable dove. It is no longer tacky. This stage is ideal for compression molding. Hence, material is inserted into the mold cavity during the dove-like stage. Following dove-like stage, the mixture enters the rubbery or the elastic stage. It's very important. Monomer is dissipated by evaporation and by further penetration into the remaining polymer beads. In clinical use, the mass rebounds when the compressed or stretched. Upon standing for the extended period, the mixture becomes stiff. This may be attributed to the evaporation of free monomer. From clinical point, the mixture appears very dry and resistant to mechanical deformation. See, you have to be thorough with these slides as you have already done the flasking, the clamping in your prostho part when you cured the complete denture or your RPDs with the self-cure or the heat cure acrylic. So these are very basic points you all know and you all go through with it. So coming on to the dove forming time, the time required for the resin mixture to reach a dove-like stage is termed as dove forming time. In clinical use, the majority of resin reach a dove-like consistency in less than 10 minutes. Important. So coming on to the packing, placement and adaptation of the denture based material within the mold cavity is termed as packing. Can you see this? Overpacking leads to excessive thickness and malposition of prosthetic teeth. Underpacking leads to noticeable denture based porosity. Trial packing is done to ensure proper packing of resin mass in the mold. After the final closure of the flask, they should remain at room temperature for 30 to 60 minutes. It is called bench curing. Very important, and I know you all know this complete procedure. Now coming on to the bench curing, it permits equalization of the pressure through the mold, allows more time for uniform dispersion of monomer throughout the mass of dove. If resin teeth are used, it provides a longer exposure of resin teeth to the monomer, producing a better bond of the teeth with the base material. Now polymerization procedure, curing. Okay, before move to curing, I have two important MCQs regarding the packing and the flasking. First MCQ, insufficient closure of flask. I repeat, insufficient closure of flask during packing of denture based resin can lead to, your answer is increase in the vertical dimension. It was asked in the AIMS. Your next question is, accepted polymer to monomer ratio for packing of PMMA, that is polymethyl methacrylate. The ratio is 3:1. I repeat, accepted polymer to monomer ratio for packing the polymethyl methacrylate is 3:1. I hope till now each and everything is clear to you guys. Coming on to the polymerization procedure or curing. When heated above 60 degrees Celsius, molecules of benzoyl peroxide decompose to yield free radicals. Each free radical rapidly reacts with an available monomer molecule to initiate polymerization. Heat is required to cause decomposition of benzoyl peroxide. Therefore, heat is termed as activator. Decomposition of benzoyl peroxide molecule yields free radicals that are responsible for the initiation of chain growth. Hence, it is termed as initiator. That's why your benzoyl peroxide acts as an initiator. Temperature rise. Because resin and dental stones are relatively poor thermal conductors, the heat of the reaction cannot be dissipated. Therefore, the temperature of the resin rises well above the temperature of investing stone and surrounding water. It should be noted that the temperature of the resin not allowed to exceed the boiling point of the monomer to 100.8 degrees Celsius, very important, which produces significant effect on the physical characteristics of the processed resin. Coming on to the curing cycle, for processing in a constant temperature water bath at 74 degrees Celsius for 8 hours or longer with no terminal boil. Processing in a 74 degrees Celsius water bath for 8 hours and then increasing the temperature to 100 degrees Celsius for 1 hour. Third one is the processing resin at 74 degrees Celsius for approximately 2 hours and increasing the temperature of water bath to 100 degrees Celsius for 1 hour. Coming on to the polymer monomer ratio. Polymerization of methyl methacrylate to polymethyl methacrylate yields 21% decrease in the volume of the material, which would create difficulties in denture-based fabrication and clinical use. To minimize dimensional changes, resin manufacturers pre-polymerize a significant fraction of the denture base. The accepted polymer, it was a MCQ which was being asked in your AIMS exam, that the accepted polymer to monomer ratio is 3:1 by volume. Using this ratio, the volumetric shrinkage is limited to 6% and 0.5% of linear shrinkage. Coming on to the polymer monomer ratio, if too much monomer, very important, if too much monomer is used, if too little monomer is used. If too much monomer is used, greater curing or polymerization shrinkage. If too little monomer is used, there is not at all polymer bead will be wetted by the monomer and the cured acrylic will be granular. In this, more time is needed to reach the packing consistency, and if the monomer is too little, duff will be difficult to manage and it may not fuse into the continuous unit of the plastic during processing. Porosity may occur in denture. Coming on to the polymerization via microwave energy. It was first reported by Kimura et al. This technique employs a specifically formulated resin and a non-metallic flask, that is FRP, that is fiber reinforced plastic flask. Advantages of this is it is cleaner and faster polymerization within 3 minutes. Minimal color changes can be observed. Less fracture of artificial teeth and resin bases. Superior denture base adaptability. Advantages, coming on to the advantages of injection molding technique. It has dimensional accuracy, no increase in vertical dimension, homogeneous denture base, good impact strength. Disadvantage: high cost of equipment, difficult mold design problem, special flask is required. Uses of chemically activated denture based resin for making temporary crowns and FPTs, used in the construction of special trays, used for the denture repairing, relining and rebasing, for making removable orthodontic appliances. Coming on to the advantages and disadvantages of chemically. Same way, better initial fit, which is because the curing is carried out at a room temperature, thus there is less thermal contraction. Color stability is inferior to that of heat cure resin due to subsequent oxidation of the tertiary amine. Next is slightly inferior properties because the degree of polymerization of the self-curing acrylic is less than that of heat-cured ones. For repairing dentures, self-curing resins are preferable to heat-cured resins, as heat curing causes warpage, or you can say heat causes distortion. What all are the techniques that are used for the manipulation of autopolymerization resins? Your sprinkle on technique, your adapting technique, fluid tracing technique, and compression molding technique. Coming on to the composition of light activated denture based resin. It consists of urethane dimethacrylate matrix with an acrylic copolymer, microfine silica fillers, and a camphoroquinone amine which act as an photoinitiator. One such product is known as VLC triad. Now, processing errors in the acrylic resin: porosity, grazing, and denture warpage, or you can say denture distortion. Types of porosity: there is internal porosity and external porosity. Internal porosity and how can be avoided. Internal porosity occurs due to vaporization of the monomer. When the temperature of the resin increases above the boiling point of the monomer or very low molecular weight polymers. Next is the exothermic heat of the surface resin dissipates easily into investing plaster. However, in the center of the thick portion of the heat can't be conducted away. Therefore, the temperature in the thick portions may rise above the boiling point of the monomer, causing the porosity. Avoided by dentures with the excessive thickness should be cured using a long low temperature curing cycle. You have to go through these slides twice. Coming on to the external porosity, it can be avoided. The cause of external porosity is lack of homogeneity, lack of adequate pressure. So lack of homogeneity is avoided by using proper powder liquid ratio and mixing it well. The mix is more homogeneous in the dough stage, so packing should be done in a dough stage only. Very important line. Lack of adequate pressure is avoided by using the required amount of dough. Check for excess or flash during the trial closure. Flash indicates adequate material. Before coming on to the grazing, I have some important question regarding the porosity. First MCQ: if curing occur at the temperature more than 100 degrees Celsius, porosity occurs at, answer is hard, thick, central area. I repeat, if curing occurs at temperature more than 100 degrees Celsius, porosity occurs at, answer is hard, thick, central area of the denture. Next MCQ is, porosity present in the acrylic denture base is usually a result of, answer is lack of sufficient pressure applied to the flask. This was a question which was asked in English exam. Next MCQ, subsurface porosity is due to, your answer is thermal changes. It was asked in your PGI exam. Next, which is very important, asked twice in AIMS and PGI, and question is, porosity will seen if resin is packed in sandy stage. I repeat the question, porosity will seen if resin is packed in sandy stage. I hope it is clear. Coming on to the grazing. Grazing is the formation of the surface cracks on the denture base resin. The cracks may be microscopic or macroscopic in size. It may be small or it may be large. In some cases, it has a hazy or foggy appearance rather than cracks. Classification of denture liners: hard or soft, heat cured or self cured, short term or long term, resin based or silicone based. Coming on to the tissue conditioners. Tissue conditioners are the soft elastomers used to treat irritated mucosa. Composition: these are highly plasticized acrylic resins supplied as the powder and liquid. powder contains polyethyl methacrylate or one of its copolymers. Liquid contains aromatic esters butyl phthalate, butyl glycolate, an ethanol or an alcohol of the high molecular weight. Uses of tissue conditioner. Ill-fitting dentures can cause inflammation and distortion of oral tissue. Relining an ill-fitting denture with a tissue conditioner allows the tissue to return to the normal at which a new denture can be made. Next is as an impression material. Tissue conditioner is also used as a impression material. Coming on to the denture adhesive. They are highly viscous aqueous solution which are often used to improve the retention of the complete dentures. Composition is cryogum, tragacan, sodium carboxymethyl cellulose, polyethylene oxide, contain some flavoring agents. Some also contain antimicrobial agents and plasticizers. So this is all about your resins. I hope it is clear. You just go through once. You can expect at least 1 to 2 questions from this particular topic. So this is all for today. Thank you so much.